All right, guys, welcome. In these series of videos, we will be taking a close look at ChemQuest27. This first video is going to look specifically at those first two student response questions, 1 and 2, in that information section entitled Percent Composition. So don't be a dud of a student. Make sure you have in front of you your periodic table and a calculator so that you can follow along. You don't want to get too good at watching Mr. Hudeberg do chemistry. You want to get good at doing the chemistry yourself. And Mr. Hudeberg is here as a support for you. So you do your part by having the tools you need in front of you. All right, now let's get going. All right, so question number 1. All right, so I am assuming you've already read that information section, right? And perhaps, if you're a good student, you even jot down a few notes in your notebook as a helpful tool to use as you build capacity here, right? But a formula from that information section, I copied and pasted that right there for us so we can use it as a reference. But question 1, it says to verify, right? So basically, when you can see these questions, it just means make sure that in the compound C4H10, percent composition of carbon is approximately 82.6%, right? So a lot of that comes down to how many sig figs we use. But if we get an answer that's close to 82.6%, that means that we can verify and say that that is a true statement. Okay, so what we need to do in this situation is we'll use our handy little formula down here. So we want to find the percent composition of element X. In this case, element X would be carbon, right? So basically what we're going to do is we're going to take the mass of X in 1 mole of the compound, right? So we're going to take the part of C4H10 that is carbon. So that's the 4 carbons, okay? So I'm going to set up my fraction. You guys all know by now that a fraction just means divide, right? I'm going to go to the top here, 4 times 12.01, right? So that would be the mass of the carbon part of C4H10, okay? So that's that part. Now what I'm going to do is I'm going to take that over the total, right? Which is going to be the total mass of the carbon and the hydrogen. So what I'm going to do is take that over 4 times 12.01 again, plus, right, we do have the other part of this compound that involves 10 hydrogen atoms. 10 times the mass of hydrogen, which is 1.01. All right, and what that would look like if I simplify this expression, so 4 times 12.01 is 48.04 over 4 times 12.01 plus 10 times 1.01. That gives me 58.14, right? Now, what we're going to do is that's going to give me a decimal value. It is asking for percent, so in order to convert a decimal value into percent, we're just going to move the decimal 2 places or multiply by 100, whatever you find easier. All right, and when we do that, we should get 82.63% carbon. All right, now, which is awfully close to that 82.6. We do have 1 extra sig fig in there. So, verified. Check. All right, moving forward. Number 2 says calculate the percent composition of sodium in Na2S. All right, so again, the percent composition of element X in this situation is going to be sodium. Right, so again, I want to know out of the whole compound, sodium sulfide, what percent of that entire compound is sodium by mass. All right, so again, what we're going to do is we're going to take 2 times the mass of sodium. So set up our fraction. We're going to go 2 times the mass of sodium, which you get from your periodic table, is I believe 22.99 over the combined mass of both the sodium and the sulfur. So we're going to go 2 times 22.99 again, plus I have 1 sulfur, so I'll just go 1 times the mass of sulfur, which is, all right, so 1 sulfur would be 32.07. All right, and so when we simplify that expression down, we should get 2 times 22.99 is 45.98. Over a combined mass of 78.04, right? And then we'll multiply that by 100, or move the decimal 2 places to the left, whichever, or sorry, 2 places to the right, and we should get 58.92% sodium.